Hello and welcome back. Let's now use the bitwise AND operator to count the number of set bits in a signed integer variable. As you can see that I have declared x there in the program as signed integer variable, and we are taking the value of x from the user. Then the purpose is to count the number of set bits in x. Now for doing that, we need to use the bitwise AND operator. The idea is that we'll be actually ANDing 32 times, because the size of x is 4 bytes. That means it contains 32 bits. So we need to check all those 32 bits if that contains 1 or not. So say if the content of x is say 11, and then the least significant 8 bits are going to be something like this 1 0 1 1, and all the rest of the 32 bits are zeros. So in order to find out the number of set bits, we'll actually start ANDing x with 1, and if we get 1, that means, as I said earlier, the least significant bit of x is 1. Then we'll be actually left shifting this 1 and we'll get 2, and then again we'll AND this 2 with x, and if I get 2, then obviously the content here in the index 1 is 1, and then we'll again left shift this 1 2 times to get 4, and then we'll be ANDing that x with 1, this 4, and if we get 4, then obviously that particular bit here is 1, but this time for this particular example it's going to be 0, so this bit is not 1, and we are not going to increment the count for this particular bit. So in this way we can just go ahead and check every bit of the variable x, and since there are 32 bits, so we'll need to iterate 32 times in a for loop, and I'll show you. I'll write that. Now one more thing that I would like to tell you, if I write something like this, say 1 less than I, and the value of I is 2, then obviously you can understand that 1 left shifted 2 times, that means it's 2 to the power 2, that's 4, right? So if I write 1 less than 3, that means 2 to the 3, that's actually 8. So we can use this idea in order to do this program. So let me just go ahead and write the for loop there. I already have declared that variable I and another variable count in order to keep the count of number of ones, and I will be used as loop counter. So I'm starting from I equals 0 and we'll go up to I less than 32. That means the last bit that we are going to check is the 31st index bit. It will be a good idea to use size of instead of that 32. So size of integer is a good idea here, because for some compiler the size of integer may not be 32, it could be something else. So I'm using that size of int, so plus I. Now we need to check if that particular bit, ith bit, is set or unset. So I'm doing this 1 less than I, and if that yields, we need to put this total thing within parenthesis, okay, and then if this yields 1 less than I, then obviously that ith bit is set. Now I hope you have understood this idea. Now 1 less than I is actually 2 to the power I, so we are ANDing x with 2 to the power I, and if I get 2 to the power I, obviously that ith bit is set. So in that case we are going to increase the count, otherwise not. Now after coming out of the loop, I'm just printing the count, total set bits equals %d \n and count, return 0, and we're done. Let me go ahead and check this program. Build and run. I'll give -1 at the very beginning because all the bits of -1 are set. That's all ones in 32 bits, so the expected result is 32. Oh, I really did a mistake there. Size of int will yield 4 here, but instead of that we need to write times 8, because we need to check bits, not bytes. There are 32 bits, size of int is going to yield 4 bytes, and 4 times 8 is actually 32. There are 32 bits. So let me just go ahead and run it once more. That was a silly mistake. Okay, so now I'm giving -1, and you can see that all the bits are set. That's 32 this time. Now again, I will just give 10. For 10, it's 1010. 2 bits are set, so the result is 2 as expected. And I can just test once more, say 100. Okay, that's 3. Great. So that's how we can use the bitwise AND operator and the left shift operator to check how many bits are set in a value, in a signed integer value. Now in the next tutorial, we'll go a step ahead and we'll see how we can print the bit configuration of a signed integer variable. And that's going to be interesting, where we'll be using the AND operator and the right shift operator. Now the things are going to be pretty same as we did here, only we'll be using the right shift. So let's go ahead and see that tutorial. Thank you very much for watching this one.